Okay, so I want to find the inverse of this matrix. Now, so the first thing I need to do to find the inverse, I need to find the determinant. So I call this matrix A. And the determinant of A, well, to set the determinant up, to get the first entry, look at the one here. If I wipe out the row, wipe out the column, I'm left with 3, 1, 4, 2. So it'll be 1 times 3, 1, 4, 2. Take away, then the second entry in the top line is a 2. Then with the 2, take out the row that 2 is in, take out the column that 2 is in, and left with 2, 3, 1, 2. 2, 3, 1, 2. Then I add on 1. And the last entry there, take out the row that 1 is in, take out the column 1 is in, and I got 2, 3, 3, 4. Okay, so we now got these 2 by 2 determinants. So to work out the 2 by 2 determinants, I multiply the leading diagonal, so it's 3 times 2, which is 6. Take away the product of the backward diagonals, so that's 1 times 4 is 4. Take away 2 times 2 times 2 is 4. Take away 1 times 3 is 3. Add 1. 2 times 4 is 8. Take away 3 times 3 is 9. So that's 1 times 2, take away 2 times 1, add 1 times minus 1, which is 2, take away 2, take away 1. So the determinant of that matrix there is minus 1. And then part B, inverse I want, so the determinant. Now then, to get the next part is the matrix of minus. Now then, we have to do for each of the 9 entries what I've just done for the determinant. Okay, so for the 1, take out the row, take out the column, so it's 6, take away 4 is 2. Move into the next entry in the top row, 2, take out the row and the column, so I got 2, 3, 1, 2, so it's 2 times 2 is 4, take away 3 times 1 is 1, and the last entry, I'm looking at these 4 numbers here, so it's 8, take away 9 is minus 1. Move into the second row, take out the row, take out the column, so it's 2 2s are 4, take away 4 1s are 4, so 4 take away 4 is nothing. Then the middle entry, take out the row, take out the column, so I got the 4 corners, so it's 1 times 2, take away 3 times 1 is minus 1. And then the last entry in that row, the one here, take out the row, take out the column, so it's 1 times 4, take away 2 times 3, which is minus 2. Then the last row, third row, 3 here, take out the row, take out the column, so it's 2 times 1, take away 3 times 1, so it's 2 take away 3 is minus 1. Then the bottom row, take out the row, take out the column, 1 times 1, take away 1 times 2, so 1 take away 2 is minus 1. And for the final entry, row, column, so it's 1 times 3, take away 2 times 2, so 3 take away 4 is minus 1. So it's the matrix of minus. Then to find the matrix of cofactors, I impose this matrix of signs on top of those values. So I keep the same values, only where I got a minus I have to change the sign of that entry, so it's going to be 2, then the 1 goes to minus 1, 0, changes sign, minus 1 stays the same, this minus 2 changes sign to plus 2, plus this one changes sign, that one stays the same. So it's the matrix of cofactors. And then to find the aggregate matrix, I transpose the matrix. So the adjugate of A is this matrix where I transpose it, and to transpose a matrix the rows become columns, so the 2 minus 1 minus 1 now becomes the first column, 0 minus 1 2 is the second column, minus 1 1 minus 1 the third column. So that's the adjugate. And then to find the inverse of A, which I'll write as A to the minus 1, is 1 over the determinant of A times Rj. So this is 1 over minus 1, the determinant of A was minus 1, and then I multiply that by the joint matrix. And outside 1 over minus 1 is minus 1, so when I take that inside the matrix, it's just going to change all the signs of the entries. So that's minus 2, 0, 1, 1, 1, minus 1, 1, minus 2, 1. So that's the inverse of matrix A. And part B tells me to hence solve this set of equations now rewriting these set of equations. Okay, then the numbers will form the matrix 1 2 1 2 3 1 3 4 2, and when I operate that matrix on x y z, that equals 1 4 4. So that is matrix A times the vector matrix of the unknowns is equal to this matrix, call it B. And then if I pre-multiply both sides by the inverse, A to minus 1, I get A to minus 1 A x equals A to minus 1 B, and A to minus 1 times A, the inverse of A times A, that's the identity matrix. So anything that I multiply the identity matrix by stays the same. So the x, y, z column vector there equal A to minus 1 times B. So to solve this then, so x, y, z equals A to minus 1, which is what we did in part A. That matrix is minus 2, 0, 1, 1, 1, minus 1, 1, minus 2, 1. And I operate that on matrix B, which is 1, 4, 4. So going across and down, my answer is going to be a column vector 3 by 1. So going across then, cross and down, minus 2 times 1, nothing times 4, 1 times 4, and I add those together. So that's minus 2, nothing, and 4 is 2. Going across the second row and down, so that's 1 times 1, 1 times 4, minus 1 times 4. So that's 1 and 4, take away 4 is 1. And then the third row, 1 times 1, minus 2 times 4, and 1 times 4. So that's 1 minus 8 plus 4, which is minus 3. So the solution is x equals 2, y equals 1, and z equals minus 3.